So far, we have dealt with situations where you had to choose from a set which contained different elements, like a set of people or subsets of a set. Now we're going to transition to studying cases when the bigger set has repeated elements. As you can imagine, this is very common. Let's say like words in the English language often have repeated elements. Now, the questions with repetitions are very difficult, or at least can become very difficult. So we won't do the hardest possible question. Instead, we will restrict our attention to some simple problems. So now, what is the question that we are interested in this video? It is the permutations, repetitions, but not all kinds of permutations. What we have is a list of n elements with possible repetitions. And now I am asking, how many ways are there to order that list? Okay. So the list can be, for example, in the example I'll do later, it's like A, A, B, C. So you have 4 letters, but 2 of the letters are repeated. And you can ask, how many words can I form out of these? Now, again, as with combinations, the final formula is very compact, and you should remember the formula, but we will do the derivation later. So what is the formula? For this, you have to do it a little systematically. So first you figure out what are the different elements. So you make a list of different elements. Or let me say distinct elements. And then you ask, how many times does the first element come? Then how many times does the second element come? And so on. So you make a list of all the elements and their number of occurrences. And the final answer is n factorial over n1 factorial, n2 factorial, 3 factorial, and so on. The question I'm interested in is how many words can I form using the letters A, B, C? So I have to use all the letters and I can put them in any order. I'm not currently concerned with if it has a meaning or not in English. Okay, so I can put A, B, C, A, C in various orders. Let's try to do it by hand without any theory and see how long it takes. So I can do A, B, C. I can do A, C, B. You can move the B here. You can move B further. You can move the C further. You can move them a little more. And maybe there are all of them. I'm not sure, but let's just count anyways. 1, 2, 3, 4, 5, 6. Oh, I'm not sure if I've counted all of them. If I put in a few more minutes, I'll probably see it. But this is the point of not doing it this way, but instead using the more compact formula above, because then we can see exactly what the answer should be. So by the formula, let's see how it goes. So first I have to list all the different elements. So the different elements are A, B, and C. Then how many times does A occur? A occurs twice. So N1 is 2. B occurs once, so N2 is 1. C occurs once, so N3 is 1. And total number is 4 because there are totally 4 of them. So N is 4. And so the answer is n factorial over n1 factorial, n2 factorial, and 3 factorial, which is 4 factorial over 2 factorial, 1 factorial, 1 factorial. And that is 4 times 3 times 2 times 1, or 2 times 1. And so that is 4 times 3, which is unfortunately 12. And so I missed some too. Let me see if I can find them here. A, B, C, A, A, C, B, A. Okay, so as you can see, counting by listing, even though it's mathematically correct, it is very prone to errors. Okay, so that's why we use this compact formula. But when you do it correctly, you do get the same answer. So that's the formula that you need to remember. It is n factorial over n1 factorial, n2 factorial, n3 factorial, and so on. where n1, n2, and 3 are the different occurrences of the distinct elements in your list. And n is the total number of elements. Okay, now what's the derivation? The derivation for this is very similar to the derivation of formula for R combinations. Again, I won't do it in full details, the derivation, because it's really complicated. Instead, I will explain why this is happening in the example above. So I want to find the number of ways of ordering A, B, C. So the trick is we pretend that the two A's are different to begin with. So for example, let's pretend that my list is now A1, A2, and then B and C. Okay, it's not in the final answer, of course, the two A's are exactly the same, but for now, let me pretend that the first A is A1 and the second A is A2. Okay, now all the elements are distinct. In fact, let me also call this B1 and C1, just to be consistent. And now all the elements are distinct. And I know exactly how many ways are there to order these, the number of ways of ordering. Is 4 factorial because there are 4 of them. But now, okay, now as before, I'll construct a map between these two sets. So on one side, I have the set of orderings of A1, A2, B1, C1. And on the other side, I have the set of orderings of A, B, C. And I'll do the same thing, I'll forget. And this time I'll forget the fact that A1 and A2 are different and that they go to the same A. Okay, very similar to what we did for combination, same trick. Now what's happening? So I ask the same question, given an ordering in the target, how many orderings of A1, A2, B1, C1 map to it? And the answer, I can write it explicitly. So let me take a fixed example. So let me take this ordering. Let's say A, B, A, C. Now, how many things in that set map to this? Well, A1, B1, A2, C1 map to it. I'm just forgetting the numbers. But also A2, B1. And this is going to happen every single time. Every time I have, let's say, A, B, C. Let's do one more. Then I'll get A1, A2, B1, C1, and A2, A1, B1, C1. These two guys map to that. And so every time I take something in the right-hand side, I have two elements in here that map to that. And so the right-hand side size must be half the size of the left-hand side. And so the number of ways of ordering A, B, C must be whatever this number is divided by 2. If you think about where this 2 came from, 2 is the number of ways of ordering A1, A2. So either you can have A1, A2 or A2, A1. And you can see that here. And so 2 is actually 2 factorial because 2 factorial is the number of ways of arranging 2 elements. And this extends to any number of elements. So if you had A1, A2, A3, that is A was repeated 3 times, then you would have any permutations of A1, A2, A3 will go to the same permutation when you drop the numbers. So when you have just A. And so you would have to divide by 3 factorial. And that is the reason you see n1 factorial show up. Similarly, n2 factorial, similarly, n3 factorial. Of course, writing this very rigorously is pretty hard, and we will do that. Okay, so that's the general idea. It's okay if you don't understand the proof completely, as long as you have a vague sense of how it's coming up from, in case you forget the formula. But the most important thing is to know the formula and remember it very well.